Hello, class. This is Mr. DeMarco again. Today's lesson is acid-base indicators. And notice the indicator word up on top is all in different colors. And that's because if you have not used an indicator before, and I'm pretty sure you have in your earth science or your bio, an indicator is going to change some sort of a color. But for us, we're going to know more about why it changes color. And we're going to use table M. So at this point, if you don't have table M out, you may want to pause the video and then go get your reference table and open up table M so we can make some quick observations to find out why an answer is what it is. First things first, though, we need to know what an indicator is. An indicator is any substance that undergoes a change in the presence of an acid or a base. This change we're going to see as a color change. When we're experiencing the color changes, I need to know then very simply, which indicator am I using and the color change that I should see based on the given pH range. If we take a quick look at table M has our 6 common acid-base indicators, the pH range at which they work, and the color change that we're going to see. Now, the reason why there's 2 colors is the indicator itself is 1 color. And depending on where you are in the pH range, it will change between 2 other colors. It will stay the same, or it will go from to the left color or to the right color. So for example, methyl orange. Methyl orange at a pH of 3.1 would be red, at 4.4 would be yellow. What that means is if I'm close to these numbers, either below or above them, I'm going to see this color change. That tells me that when I'm using table M, I have to be careful of which indicator I'm using and what the number is. And that's because the color on the left represents the pH number to the left or something close to it. And the color on the right represents the pH number to the right of that sequence. You're never going to be given numbers in the middle. It's always going to be on the left side or the right side of the numbers given. Sometimes you'll see a different intensity. If it says it's going to turn red, well, a deeper red just means there's more ion present. But all we need to see is a faint color red to indicate what the pH actually is. When we do acid-base questions involving indicators, sometimes it's very simple. What color will this be at this given pH? Other times, we're going to have to use our general acid-base knowledge and be careful of what the question's actually asking. Let's take a look. Here we have our copy of table M. Now, again, as I mentioned before, methyl orange is actually orange. And what we said was if I'm around this number, so let's say I am 3, I know methyl orange is going to look red. If I'm at 4.6, it's going to look yellow. But what happens is this color change is going to be visible even if I'm below that number. So 3.1, it's red. So if I'm even 2.5, I'm going to have a red color for methyl orange. Now, what I might notice is the lower that I go, the deeper or darker the color that I see. Same thing, my color could be lighter in intensity as well. Not hard to do as long as you have table M and some knowledge of acid-base chemistry. Let's take a look at some examples. What color would a solution with a pH of 6.1 be in bromothymol blue? So 6.1 bromothymol blue. So again, you got to be careful. On table M, there's bromothymol blue and there's thymol blue. The question said bromothymol blue, so I know I'm here. It said a pH of 6.1. Notice 6.1 is right around 6.0. So that means the color that I should see is yellow. And the reason for this is bromothymol blue is actually green. We use it in class. And it turns either blue or yellow. So at 6.1, I'm closer to the 6, which means I'm going to be yellow, which means my answer has to be then yellow. Look up the right indicator, compare my pH numbers to see which side I'm on, pick the right color. Pretty easy. Number 2, what color would a solution with a pH of 10 be in thymol blue? So now I have thymol blue at a pH of 10. Thymol blue, pH of 10. Notice I'm closer to 9.6. Therefore, I'm going to be on the right side, which is a blue color. So let's take a look. Thymol blue, pH of 10. We're going to be blue. Okay. When it comes to the color change indicator questions, they're pretty easy. Other questions, though, do involve a little bit more work. Take a look at number 3. What solution would turn phenolphthalein pink? So notice there's no number there. It just says phenolphthalein pink. So if I go to table M, phenolphthalein can only be pink when it's 9 or above. So now I need to know my acid-base general information. 9 or above on the pH scale. That's a base. Bases have to have hydroxide. Notice in my 4 choices, only letter C has KOH. A, B, and D all have an H in front, telling me they're all acids. So my answer has to be C. Now, the other reason why you need to know your acid-base chemistry is they might throw in this question our good old friend ammonia, NH3. It's not your characteristic base, but it's still a Bronsted base. It would still have a pH of 9 and above. Again, these questions tend to be the easier ones of acid-base chemistry. Using your reference table and your knowledge of acid and bases, quick, easy to do. So now it's your turn. You're going to then stop the video. You're going to access the worksheet. As always, fill it in, return it to me to get your credit. Hope you enjoyed the video. If you need to watch it one more time, please feel free to do so. Have fun. Try some chemistry. DeMarco out.